Hello, good afternoon, everyone. I hope you can see my screen, everyone. If you can see, can you type S in the chat? Okay, thank you. Welcome, everyone. Today, myself, Keith Reddy. I'm I'm presently in Mangalore. I'll be hosting you for this section. Today, we'll be mainly seeing on what is surface chemistry and what are the types, what things we'll be talking about it. We'll be seeing in the next section, in the next slide. Is my voice audible? If it's audible, can you type it in the messages? Is my voice clear, everyone? Okay, let's continue. So, by this name itself, what do you understand by surface chemistry? Like the chemistry is depending on the surface of the object, right? So, the main thing is in theme of the chapter, it's also that itself. That is, we'll be discussing what chemistry, what reactions are going on the surface of the object or surface of the molecule. See, you can see few molecules right here. So it will be interacting with the molecules on the surface and some things will be happening. So we'll be seeing what are those things and how different are they from each other. For today, our objective is to learn about what is the difference between adsorption with a D and absorption with a B, right? There is a difference between absorption with a B and adsorption with D, right? A lot of difference. And then we'll see what is the mechanism, how it is undergoing the adsorption and all, and how many types of absorptions are there again, adsorptions, how many types are there again. And in that types, that is nothing but physisorption as well as chemisorption. What are the characteristics of physisorption and what are the characteristics of chemisorptions? We'll be seeing that briefly, no issues. Now, first type, that is adsorption, and its types. In that, we'll be seeing absorption. You have seen this in your daily life, right? Yes or no? I guess you have seen where you have anytime did you take any paper towel or let's say paper itself and put it on water. What happens? The water molecule will be absorbed into the surface paper, right? It will go inside the paper, right? Yes or no? No, the same thing we are here we are seeing here. That is, one substance is uniformly distributed throughout the bulk of other substance. Now here you can see the diagram, right? Now here surface, you can see the animation here. We are giving some absorbent so that it is going inside the surface of the adsorbent and they are uniformly distributed inside the bulk like this. They are uniformly distributed everywhere inside the bulk. You're getting the point? Now this uniform distribution is called as absorption. What happened in absorption? Whatever we have given, it is going inside the bulk of the surface and distributing uniformly inside it. Okay, remember that. And next we'll be seeing adsorption with a D. Adsorption with a D, right? With a D. Now previously I have seen absorption with a B. Now what happens in adsorption? Now as you can see here, there is a metal bar. Let's say this is a metal bar on a solid surface. Let's say. Now what happens here? The solid surface will act as a adsorbent now, which is the surface for other molecules to get adsorbed. Now these pink molecules you have seen, are known as adsorbate, are known as adsorbate. Now, these adsorbate molecules will be adsorbed over the adsorbent, nothing but the solid surface, which is providing the surface for other molecules to come and attach on it, are called as adsorbent, and the molecules which are coming and being adsorbed are known as adsorbate. Understood the difference between adsorbent and adsorbate? Class? Now, let's say I'm taking a platinum metal here. Let's say this is platinum metal. And what is happening in air? H2 molecules are there. Now, what is happening? They are coming and attaching over the surface of this platinum molecule. Now, here adsorbate is what? Hydrogen atoms. And adsorbent is what? Platinum. Adsorbent is the platinum, which is providing the surface for hydrogen molecules to get attached on it. Clear? That is the main difference here you need to observe. Now, the adsorbent is known as provide surface for adsorption, and these may be solid. You can see here what happened. Hydrogen is adsorbed over platinum, that is a solid. Or sometimes you have seen cool drink, right? What is happening? Let's say we are taking gas and providing into the liquid. Now, there liquid will be acting as a adsorbent. Now, the gas which we are using in both the cases is nothing but adsorbate, which is accumulated at the surface of adsorbent. Now, adsorbate may be solid, liquid, or gas, whatever it is, adsorbing over the surface. Are you clear with adsorption and absorption? What is the main difference here? In absorption, the molecules, the adsorbate molecules are going inside the bulk, but in adsorption, the molecules are being on the surface of the metal itself, surface of the adsorbent itself. That's it. Clear? Now you can see here once again, adsorption versus absorption. Adsorption with a B, adsorption with a D. Now see here, in first case we have seen absorption. What is happening? The gas particles, these are the gas particles which are going inside the solution or inside the solvent which are using, and they are going inside the bulk of the solvent in uniformly. Clear? Now come to adsorption. Adsorption. What is happening here? The gas particles which are present around it are being attached over the surface. They are not going inside the surface. Are they going inside the surface? No, they are not going inside the surface. In adsorption, the molecules present around it are adsorbed on the surface, but in absorption, the molecules are going inside the bulk of the surface uniformly and distributed uniformly. Understood the main difference here? Now next, now see here, it's a good animation for you so that will be able to understand more better. First, see absorption. What is happening here? These white molecules are going inside this green, totally inside, right? Yes or no? Absorption. That is absorption. No, these white are nothing but adsorbent or adsorbate. Which one? Now, these white molecules are nothing but adsorbate. Now, this green molecule is adsorbent. Now, come here. What is happening here? These green molecules are adsorbed over this black molecule. They're not going inside the black molecule. Understood the difference between adsorption and absorption? Any questions till now? Class, do you have any clarifications? You can post it in the chat. If you are clear with adsorption and absorption, please click a yes there. class. I hope it is clear. So we'll moving on. These are few examples of adsorbents. This is charcoal. So how many of you used muddy water and charcoal to purify the water? Nothing. You need to pack a small hole, or let's say small pipe with charcoal and pass the muddy water through it. What happens after passing through it slowly? The mud and other particles will be absorbed on the charcoal, and the pure water will be coming out of it. So this is how we use charcoal for purification of water. So, right, what happens here? The impurities will be absorbed over the charcoal surface. Now, this is nothing but charcoal is acting as a adsorbent. Now, the impurities which are being absorbed are known as adsorbate. No, silica gel. So, have you seen this class? I think you know have seen this sachets, right? Have seen post AS there? Silica gel. So these can be seen if you are buying some shoes or fridge also. They'll keeping this silica gel sachets inside the fridge. So that what happens? What does this silica gel sachets do? They will absorb the water so that they'll not be any presence of humidity inside the object what we are purchasing. Right? So that nothing will be like will not destroy any fabric inside or something like that. So what happens here? The silica will be absorbing water into it and removing the water molecules present in the atmosphere. No, alumina gel. This will also absorb a certain amount of water. It's a good adsorbent of water. So here, alumina gel, we generally use this in chromatographic plates. Chromatographic plates. This you will be seeing in future, no issues. So how to do chromatography and all. It is a very interesting topic. You'll be liking it. So these are the few adsorbent examples here. Hope you understood the examples properly. I think you are able to imagine it, how they are absorbing. The adsorbate will be adsorbed on the surface. It will attach on the surface. That's it. That is nothing but adsorption. Now see here. Adsorption, how it occurs and all. Now molecules, let's take a container like this. Let's take a container like this. And inside there is gas molecules. Firstly, we are taking only gas molecules in it. Now what happens? The gas molecules, will they stay at a particular point? No. Generally what happens? The gas molecules will go in a random fashion and colliding with every particle like this. It may collide with this particle, it may collide with this particle, it may collide with this particle. We don't know, right? It will be going in a random fashion. And at a certain point, this may also collide with the walls of the container, which exerts some pressure inside the gas container. Yes or no? So now this, what I am doing after this all observation, I kept a small adsorbent inside the small adsorbent inside the gas container itself. So everything will be colliding. So at a certain point, each molecule will collide the adsorbent also, right? So what happens at that time? Now these molecules will be adsorbed on the surface of the adsorbent. This pink molecule, which is called as adsorbate, is adsorbed on the adsorbent in this way. So what happens now? Let's say I'm here, pressure is P1, let's say pressure of the gas is P or P1. Now what I'm doing, I'm increasing the pressure inside, increasing the pressure. The adsorption will increase. So let's say the pressure is P1 now, and these molecules are one by one attaching over the adsorbate. Now, as the molecules are absorbed on the adsorbate, number of gas molecules, in this case 1, let's say at time t is equal to 2 seconds. So let's say 2 molecules are adsorbed here. So number of gas molecules initially and after 2 seconds, how many gas molecules decreased? 2 gas molecules decreased. In the same way, as the time is going on, number of gas molecules adsorbed on the adsorbent on the adsorbent increases. That means number of gas molecules inside the container are increasing. Inside the container are increasing. The number of gas molecules adsorbed on the surface are increasing, right? So that means the gas molecule in the atmosphere are decreasing. See here, less number of gas molecules, less number of gas molecules. Now what is happening here? As the gas molecules decreased in the container, the pressure also decreases. The collisions will decrease, right? So that the pressure also decreases. As adsorption is going on, as the adsorption process goes on forward, the pressure inside the container, closed container, will decrease. Now, this is how we can prove that gases are adsorbed by adsorbent. Class, are you understanding the class? Can anyone, if anyone has any questions, they can post it in the chat. No questions. It's a surprise. But yeah, let's continue. Now, let's speak some basic terms which are related with adsorption. What are the terms we'll be speaking? Until now, what we have seen, the gas molecules were attached over the surface, nothing but the gas molecules which are called as adsorbate are adsorbed on the adsorbent, that is the metal surface, right? We have seen this. So this process where the molecules are being adsorbed on the surface are known as sorption process. It is known as sorption process. Adsorption and absorption take place simultaneously. If you see in this example, what is happening? Some water molecules are present on the surface. That is, if they are present on the surface, it is called as adsorption. And this towel is also absorbing the water molecule, which is going inside the towel fabric also. That process is known as absorption. Now here, both processes are happening. This is known as sorption. If it is taking adsorption also, we'll call it as sorption. If absorption is also happening, we'll call it as sorption. Both are same. Fine. But the difference between adsorption and absorption is, in adsorption, it is over the surface only. Over the surface. But when you come to absorption, it is inside the bulk of the solution. Inside the bulk of solvent or solution. Here, the molecules, adsorbate molecules are going inside the bulk. Here, in adsorption, they are present over the surface only. Now come to desorption. What is happening? What can you see in the animation? The green molecules, can see the green molecules, right? What is happening to the green molecules? Initially, they were on the black surface. And what is happening? After some time, they are going away from the surface. Exactly reverse to adsorption or absorption, right? Exactly reverse to sorption. What is happening here? The molecules which are adsorbed on the surface are being removed, which are going into the other medium. The reverse process of sorption, nothing but desorption, process of removing adsorbate from surface of adsorbent. This is nothing but desorption. Understood the difference between sorption and desorption? Class, are you understanding the class? Okay, you can put it in the chat. Let's move on to the next slide then, if you don't have any doubts. This is a quite an easy chapter. If you are understanding the concept, it will be easy for you to answer the questions also. So don't worry about it. Now we'll see how the adsorption process is happening. You know that the adsorbate is going and attaching on the adsorbent, but how and why they are attaching actually? We'll be seeing that. Now for that, there are two aspects. One is net force on the particle what type of forces will be acting on the particles, like such, let's say adsorbate and adsorbent, what kind of force will be present between them. And one more thing we'll be seeing, that is thermodynamic aspect, how thermodynamics will be affecting the adsorption process. These two will be seen. Okay. Now first let's see net force of attraction. Now see here, this green one is nothing but, let's say, bulk particle, the adsorbate particle itself, which is present inside the adsorbate. Okay. Now if let's say this is the metal piece, now this particle is present inside the metal piece. Okay, that's what I'm saying. If it is water molecule or if it's any solvent, it is present inside the solvent. Okay. Now what happens? This green is surrounded by same amount of molecules on the each side, right? Yes or no? Now like this water molecule, or let's say this solvent molecule, is surrounded by all the solvent molecules, right? Same solvent molecules on each side on 360 degrees, right? So there may be attraction or there may be repulsion in the solvent. They also have some attractions, right? That is why it is a liquid or it is a solid. So let's say we will be talking about attraction force. Now there is a force of attraction between these two from left, these two from right, from up, from down, and everywhere there is equal and opposite attraction forces, right? If it is attracting from the left same side, same molecule is present on the right side also. So there will be equal attraction on left as well as right. So on a whole, in 360 degrees, if we see, the net force on this green molecule is how much? 0. It is balanced, right? On 360 degrees, you are having same molecules and same attractions. So on a whole, what happens? Each will be cancelling out opposite one. And what happens? The net force will be 0. So what we can conclude from this is the bulk, whatever the solvent particle or adsorbate particle is inside the bulk, will have a net force of 0. Now come to surface. Now let's see this surface or this surface. The molecules present on this surface. Now at surface, this red molecule, is it surrounded by the solvent particles in 360 degrees? No, it is surrounded by this surface particle, left and right. One is down, but is there anything above? No. Is there? Air is there, right? So it is a different medium. So if you see here, the left and right particle net force is cancelled out, but the below and side particles net force is not cancelled out. So obviously there will be some kind of forces on this other side also for this. Now there are gas particles in the air also, right? This blue one or this red one which I'm drawing, these are the gas particles present, right? So what happens here? These gas particles also attract each other. There are some kind of forces between molecules, right? Known as van der Waals forces. Now let's say leave it for now. Let's say some forces are acting between these molecules. Now, as these molecules are same, the left and right molecules, we can say that these green molecules, left and right molecules as same molecules, the attractions will be same and these forces will be cancelled out, right? That is the first point. Now, when we come to the particles which are present outside and which are present inside. Now, this force cannot be cancelled by this force, right? Yes or no? Because both are different molecules, both have different type of attractions, right? So that is the reason the net force on the particles, surface particle, which are present on the surface is not 0. Net force of attraction is not equal to 0 for surface particles. Net force of attraction for surface particles is not equal to 0. Why? Because they are not surrounded on 360 degrees by same particles. But in bulk, what happens? They are surrounded by same particles, right? So that is the reason we say for bulk particles, the net force is equal to 0. Understood? Now, because of this difference in force, the surface particles will adsorb the gas particles. Because of these attractions, because of this difference in attraction, each adsorbate or each adsorbent has different type of attractions between adsorbate. Are you clear with the net force of attraction? Plus, how it is differing for a particle inside the bulk and how it is differing for a particle at the surface of the bulk. Class, if you answer, I'll be moving to next slide. If you are understanding, enter S. Class, reply in the chat. Okay, fine. No issue. Let's move on to the next slide. Now, see here, due to this adsorption, due to this imbalance in the force at the surface molecule. Good afternoon, good afternoon. Join the class. I hope you can understand. Now, the adsorption at the surface molecule, why it is having adsorption force? Because it is surrounded by different molecules and the net force on the particle at the surface particle, the net force is not equal to 0. Net force of attraction at the surface is not equal to 0. Now, because of this difference in the force, this extra force inside and there is no force outside, this surface particle will be attracting the particle, because of which adsorption takes place. Adsorption takes place because of the imbalance in the force. Okay. Now let's talk about the thermodynamic aspect of how the adsorption is taking place and what is the thermodynamic reasons why adsorption is favorable or not favorable. First thing we'll be talking about is change of heat of adsorption. That means nothing but enthalpy. What enthalpy term will be affecting the adsorption process, and then we'll see what entropy term, how the entropy of the compound is changing and how it is affecting the adsorption process. After talking about these two effects, that is enthalpy and entropy, we'll be seeing Gibbs free energy, whether the reaction is spontaneous or non-spontaneous, right? If delta G is negative, the reaction is spontaneous or non-spontaneous? Class, reply in the chat. If delta G is negative, the reaction is known as spontaneous reaction or non-spontaneous reaction. Option A, spontaneous. Option B is non-spontaneous. If delta G is negative, enter the options A or B. Good. From JNB Mahe. Good. The option is correct. That is, if delta G is negative, it is a spontaneous process. Now let's see how the delta enthalpy term and entropy term will be talking. Now first see what happens when a reaction is happening. Now here A molecule is there individually and B molecule is there individually. What is happening here? Both are reacting and forming bonds. Let's say this is A and this is B. Now what is happening? It is forming a bond between A and B, right? It is forming a bond between A and B, because of which energy is released. Energy will be released, right? If energy is released, enthalpy will be known as negative enthalpy. That is, the negative sign represents the energy released. Now, let's say this formed molecule is there. I want to separate it. What we need to do? I need to break the bond between AB, right? I need to break the bond, which requires energy to break the bond, right? Here, energy will be given to the system. The positive sign indicates the energy given to the system to break the bond between A and B. Now, this bond, in the first case, bond is formed due to attraction between the molecules, right? Attraction between the adsorbent and adsorbate molecules. Because of this attraction between the molecules, the energy is released, right? Now here we are not breaking the bonds in adsorption. We are making the bonds. What type of bonds we'll be making here? Each molecule has certain type of dipoles, right? Or let's say van der Waals forces between the molecules. Now these van der Waals forces will be attracting the molecules. Now this is adsorbent surface, right? Now there are molecules in the atmosphere. They will have some van der Waals interactions between each other, which will help to form the adsorption process. Now coming to next term, that is entropy term. What happened in enthalpy? Because of formation of the bond, that is van der Waals forces between the adsorbent and adsorbate molecules, the energy was released. Somewhat energy. Van der Waals forces are weak forces, right? So let's say only some energy is released, not high energy. But even the small amount of energy is released also, it gives some spontaneity there. Now let's see what happens to the entropy term. We have seen, right? There was a container first, and there was a adsorbent here, and the gas molecules are inside the container. What happened after certain time? These gas molecules were adsorbed on the surface, right? Number of gas molecules in the container decreased. Yes or no? No. As the number of gas molecules in the container decreased, number of gas molecules when T is equal to 1 to T is equal to 2 decreased. That means the number of randomness of the molecules which are colliding with each other is decreasing. Here, as time is increasing, the number of gas particles decreases, right? So as they are decreasing, number of collisions are decreasing. That means randomness is decreasing. So indirectly, what is happening? Delta S is decreasing. You can see, right? Adsorbate is being adsorbed on the surface. First case, adsorbate is being adsorbed on the surface. Now, because of this, number of gas molecules in the container decreased, because of which randomness decreased. That is nothing but entropy is decreasing. Entropy is not increasing here. Entropy is decreasing, right? So what is happening regarding enthalpy? Because of formation of the new bonds, enthalpy was released. Now what happened to entropy? Because of adsorption process, the adsorbate onto the adsorbent, randomness decreased, entropy decreased. Enthalpy was released, energy was released, enthalpy was negative, and entropy was decreased. Entropy is also negative. Now let's see what is happening here. Energy relation between delta H, delta S, and delta G. All of you know this very well equation, right? Delta G is equal to delta H minus T delta S. Now, we have seen in the previous case, what is delta H is delta H is negative because energy is released, right? Now, delta S is also negative. Why delta is negative? Because randomness is decreasing. Randomness is not increasing there. Randomness is decreasing. Now, if delta H is negative and delta S is negative, this minus T delta S, if you substitute the negative term here, it will give us a positive T delta S, right? Yes or no? Now write the new formula, and delta H will be minus delta H. Substitute both here. Delta G is equal to minus delta H plus T delta S. Now this is what is happening in the adsorption process. Now let's see how these terms are affecting adsorption. Now see, at low temperature, what is happening? T delta S term is less, right? At low temperature, let's say first case is delta H is less than T delta S. If that's the case, delta J will be equal to negative, right? Yes or no? Let's say this is 2 and this is 1. Minus 2 plus 1. What it will be? Minus 1, right? So if delta G is negative, it is nothing but a spontaneous process. Now come here. If T delta S is equal to delta H or T delta S is greater than delta H, what happens in both the cases? This positive term, this is first case and this is our second case. Inverse the number here. -1 plus 2. What happens? +1. Now delta G is positive term 0, or if it is 0 first case, no, if it is 0, the adsorption process is at equilibrium. How many molecules are adsorbed on the adsorbent are equal. The same number of molecules are coming out of the adsorbent. See here. Now let's take this as a surface. Let's say one molecule is being adsorbed on the surface initially. Now at this case where delta H is equal to T delta S, the same number of molecules will be coming out. Adsorbing and desorption. The sorption process, how many molecules are being adsorbed, will be equal to desorption process. This is when delta H is equal to T delta S. This is the case. Now, if delta H is less than T delta S, what happens? Delta G will be, if this is the case, delta G will be positive, right? What is happen? Is it a spontaneous process? No, it is non-spontaneous process. Why it is non-spontaneous process? As we increase the temperature, let's say, as we are increasing the temperature, what happens? The kinetic energy of the surface molecules increases. Yes or no? Now, because of this increase in energy between the surface molecules, it can easily go out of the surface into the air. The gas molecules will be returning to the air easily because of high kinetic energy of the gas molecules. Understood? What happens when delta H is less than T delta S? The adsorption will be a spontaneous process. And at delta H is equal to T delta S, what happens? The adsorption, sorption, and desorption process will be in equilibrium. Both will happen simultaneously. How many molecules are being adsorbed are equal to how many molecules are desorbed. Fine. And come to third case, what happens when delta H is less than T delta S? What happens? Delta G will be positive, which is a non-spontaneous process. Why it is a non-spontaneous process? As we go at high temperatures, the kinetic energy of the gas molecules adsorbed over the surface increases, because of which they can easily go into the gas medium again back, which undergoes desorption process. Now let's talk about adsorption and its types. Until now we have seen what is adsorption, what is absorption, and how adsorption takes place based on force as well as thermodynamic terms. What was the force term we talked about? At surface there is imbalance of the force, and in the bulk there is equal force on 360 degrees, right? Now because of this imbalance at the surface, there was attraction between the molecules in the air and the adsorbent. Now after talking about force of attraction, we came to thermodynamic term regarding enthalpy, entropy, and Gibbs free energy, right? So now we'll be seeing which type of attractions will be present between the molecules. That is the surface molecule, that is adsorbent and adsorbate, whether they are normal interactions or any strong bonds or weak bonds. Now, depending on it, there are two types, that is physical adsorption and chemical adsorption. The physical adsorption is known as physisorption, and chemical adsorption is known as chemisorptions. Class, if you have any doubts, you can post it in the chat. Don't forget that. One is physical adsorption and other is physisorption. One is chemical adsorption and chemisorption. Let's see what is this physical adsorption and chemical adsorption. Now see here, as I talked about, van der Waals forces first, right? The molecules possess some kind of dipole like that, or induced dipole, or hydrogen bonds. These are the three types of van der Waals forces, right? How many types of van der Waals forces? Van der Waals forces are, one is due to dipole, one is London forces, London dispersion forces, right? And one more we can see as H bonding forces, right? Hydrogen bonding forces. There are three types which will be talking. Now let's see here. Your question is from JNV Mahe. If change in enthalpy is less, let's go back. Let's say, what is the final equation we are getting? Delta G is equal to minus delta H plus T delta S. If change in enthalpy is less than T delta S, then G must be positive, right? No. Delta H is less than T delta S. This is the condition, right? Now delta H is negative, right? Then T delta S is greater than delta H. The total value will be negative or positive here? Positive value, right? Now why delta H is negative? Because energy is released while adsorption. Energy is released while adsorption. And while adsorption, the number of gas molecules are adsorbed on the surface, which gives the entropy decrease, right? Yes or no? Entropy is decreasing, delta S value is decreasing. That is the reason minus T delta S was converted into plus T delta S, and plus delta H was converted into minus delta H. Are you understanding? Jenny Mahe, is your doubt clear? I'm repeating. See again. Delta G is equal to, as the entropy energy or as the enthalpy energy is released, delta H is substituted as minus delta H, and T delta S minus T delta is there, right? As the entropy is decreasing, that is delta S is negative. Entropy is decreasing, right? Delta S is negative. So on a whole, minus T delta S will be plus T delta S, right? Now substitute this term, that is delta H enthalpy is less than T delta S. Yeah, we discussed about the equation, right? How it will change. Delta G is equal to minus delta H plus T delta S. The actual equation is this. After the reaction is going on, as the reaction is going on, as the adsorption process is taking place, now the equation was converted into this. Yes or no? Now, because of this equation only, here, what is happening? The spontaneity is changing. Are you clear? Delta H is less. That means on a whole, delta G will be positive, which gives us a non-spontaneous reaction. Now, same value, substitute. At low temperature, what happens? T delta S value is less than delta H, right? T delta S value is less than delta H. I'll write the equation again here. See here. At low temperature, delta G is equal to minus delta H plus T delta S. What is the condition? At low temperature. That means delta H is greater than T delta S. Yes or no? Now on a whole, what is happening? Delta G will be negative as delta H is more than T delta S. If delta G is negative, this process will be spontaneous process. I hope you are clear. Can you reply in the chat? Can you reply fast because the timing is going? Okay, thank you. Now coming back to type of adsorption, as you know, there are three type of van der Waals forces, that is dipole force, dipole-dipole, induced dipole-dipole, and hydrogen bonding forces. Right? Now, these type of forces will be present. Now, when we compare these forces with the ionic bonds or covalent bonds, which one are more strong? The question is, which bonds are more strong? Option A is van der Waals bonds, van der Waals forces. Option B is ionic or covalent. Tell me in the chat, class, which bonds are stronger, van der Waals force of attractions or ionic or covalent force of covalent bonds? Ionic or covalent bonds are the strongest one. Good, Mahi, you are fast. Jane Mahi, right? Now, as these bonds are weaker bonds, these can be formed easily as well as broken easily, right? The energy released is less and this can be formed easily as well as these can be broken easily by giving some amount of energy itself. We can break this bond. This is nothing but physis option, as they are only physically. They are not actually forming a bond. Van der Waals bond is nothing but attraction between two molecules. That's it. So they are having only a physical phenomena. They are not actually forming a bond. Now, when we come to Chemis option, what is happening here? They are actually forming a ionic or covalent bond. They'll be reacting with the surface of the metal. Or if it is adsorbate, right? Adsorbent. Now, this adsorbent will be reacting with the adsorbate. It will be reacting with the adsorbent. No. And after reacting, it may form covalent or ionic bond, which is a strong bond, which we need to provide to more energy to break it. Now, as it is undergoing a chemical reaction, it is known as chemisorption, as it is undergoing only a physical phenomena where attractions between the molecules are superficial. This is known as physisorptions. What is the difference here? In physical adsorption, that is physisorption, only physical interactions are there. They are not actually forming a strong bond. Now, when we come to chemisorption, they are actually reacting. The adsorbate and adsorbent are reacting with each other and forming a new covalent or ionic bond between each other. Clear? Now, let's see characteristics of, okay, the time is already up. Let's summarize. What do you say? Can you unmute yourself or should I unmute you? Let's summarize. Firstly, what we did, we started with surface chemistry. That is nothing but we'll be discussing what happens at the surface of the adsorbate and adsorbent, how they are interacting. That we have discussed, right, in surface chemistry firstly. And then we have seen what is the difference between adsorption and adsorption. Absorption. What is the difference between adsorption with a D and absorption with a B? What's the difference? In adsorption, what happened? It was present only on the surface. Now, what happened in the absorption? The adsorbate went inside the bulk of the molecule. If this is a solvent, the adsorbate went inside the bulk in homogeneous way. Now, what happened in adsorption? It was only on the surface. It was not going inside the bulk of the surface. That is the main difference here. Now, after talking about this, we have seen more about adsorption, right? How adsorption is taking place, right? Now, what are the terms involved in adsorption? One is sorption. Another one is desorption. Sorption is nothing but adsorption process where the adsorbate is being attached on the adsorbent surface. Desorption is nothing but the adsorbate which is present on the surface is being removed from the adsorbate surface. Now we have seen adsorption was dependent on two terms, that is enthalpy, delta H, and entropy, delta S. What is happening as they are forming new bonds, they are having small van der Waals force of interactions or covalent or ionic bonds which are being formed, newly bonds are formed between the adsorbate and adsorbent. energy is being released, that is nothing but delta H will be equal to negative. And what is happening? As the adsorption process is going on, the number of molecules present in the air are decreasing, right? The number of particles are decreasing. That means randomness is decreasing. Entropy is decreasing. Entropy is negative. Now, after talking about these two terms, and we talked about Gibbs free energy delta G, nothing but delta H minus T delta S. Now, if you are substituting those both of these terms here, this is nothing but minus delta H. This is nothing but minus delta S. If you are substituting both here, minus delta H minus of T minus delta S, that is nothing but minus delta H plus T delta S. This is how the reaction equation changed, right? Now, because of this, at low temperature, what is happening? Delta G was negative. Delta H term is more right here, as at low temperature that T delta is less. So delta G was negative and the spontaneous adsorption process was spontaneous. At high temperature, what happened? Delta H was greater than T delta S and delta G was positive, because of which we said that it is a non-spontaneous process. Now what happens if delta H is equal to D delta S? That time delta G will be equal to 0 and the sorption process as well as desorption process will be equal. So the adsorption process will be in equilibrium. We talked about this, that is net force of attraction and the entropy values. What happened in net force of attraction? In the bulk, it is surrounded by the solvent particle is surrounded by 360 degrees, right? Because of that, net force of attraction is equal to 0. But what happens at surface, as it is not surrounded on 360 degrees, only half part is surrounded or unequally surrounded. Because of that, the net force of attraction is not equal to 0, because of which this will be attracting the gas particles present in the other medium. These are the two terms we talked about, right? Then after this, what we talked? Adsorption is of two types. Adsorption is of two types, that is physisorption. What is physisorption? Nothing but only physical phenomena. Only the van der Waals force of attractions are present in the between the molecules. It is not a strong bond. This is a weak force of attraction between molecules. It can be broken easily and formed easily. Now, what is another type here? Chemisorption. How chemisorption is happening? It forms a strong bonds between the adsorbate and adsorbent here. What is adsorbate? What is adsorbate? The molecules which are being adsorbed are called as adsorbate. And this surface which is given is called as adsorbent, right? Now, chemisorption is because it is forming strong bonds between each other. That may be covalent or ionic bonds. In physisorption, what type of bonds are involved? Van der Waals bonds, van der Waals forces are involved. Van der Waals forces are involved here. I hope the class is clear. If you have any doubts, you can post it now. Until now, we have covered these many topics. And if you have any clarifications regarding this, post it in the chat now. Tomorrow we'll be seeing characteristics of physisorption and characteristics of chemisorptions. Class, if you are clear with the class, you can press yes in the comment section. If you understood the class, press a yes in the comment section, chat section. If you have any clarifications, do clarify. Okay, JNV Rajkot answer that is clear, sir. What happened to others? Are you clear or not? Have any few things in your mind, you can say it here so that I'll be going more deep into those topics. If there is no interaction, I'll not understand like whether you are understanding or not, right? As I'm not able to see your faces. So do reply in the chat, everyone who's present in the meeting. Come on, you can answer these. Come on. If you are clear, just press yes in the comment section. Fine. If you are clear, then let's end the section for today. Have a good day, everyone. You can leave the meeting. Have any questions, you can post it here. I'll be waiting.